Hi, this is Jeline from the Honors Tutorial. Our topic for today is about limits of exponential functions for Mathematics 11. Example number 1, we have here the limit of 4 raised to x as x approaches to 0. So let's solve. Let's have our solution here. Kindly copy the given. So that is the limit of 4 raised to x as x approaches to 0. So let us do the direct substitution. So 4 raised to x will become 4 raised to 0. And then any number or any letter that you raise to 0 is equal to 1. So therefore, the answer is 1 for example number 1. Next, for example number 2, we have here the limit of 8 raised to 3x minus 2 as x approaches to 1. So let's write our solution here. And then copy the given. So that is the limit of 8 raised to 3x minus 2 as x approaches to 1. So let's do direct substitution. So we have here 8 raised to 3 times 1 minus 2. And then let's simplify 3 times 1. So that is 8 raised to 3 times 1, that's 3, minus 2. So let's continue solving for the exponents that we have. So that is 8 raised to 3 minus 2, that's 1. So now we have here 8 raised to 1. When we simplify it, that is equal to 8. So that's the answer for example number 2. Let us have our next example. So now we have here example 3, the limit of the quantity of 3 over 5 raised to 3x plus 1 as x approaches to 2. So let's have our solution here. Let's copy the given first. So that is the limit of the quantity of 3 over 5 raised to 3x plus 1 as x approaches to positive 2. And then let's do direct substitution here. So we have here the quantity of 3 over 5 raised to 3 times the value of x, that's 2, plus 1. So let's continue simplifying the exponents. So we have here the quantity of 3 over 5 raised to 3 times 2, that is 6, plus 1. So let's continue. So that is the quantity of 3 over 5 raised to 6 plus 1, that is 7. This is not the final answer yet, so let's continue solving. Make sure that your exponents will be evenly distributed in your numerator and in your denominator. Okay, so that is 3 raised to 7 over 5 raised to 7. So let's simplify. What is 3 raised to 7? And that is equal to 2,187 over 5 raised to 7. That is equal to 78,125. So let's just check for now if it's still or if it can be simplified, for this form as fraction, this is the simplest form because of two reasons. The first reason is that it is a proper fraction, meaning the numerator is less than the denominator. The second reason is that there's no number that can divide the numerator and denominator at the same time without remainder. But you can also change this into decimal form. So let's write or here. If we're going to divide this 2,187 divided by 78,125, so that is equal to 0.02799936. Or we can just simplify it and write 0.03. So that is the answer for example number 3. And this is our last example. We have here the limit of 4 raised to 3x minus 3 raised to 4x over x. So solution, let's copy the given. So that is the limit of 4 raised to 3x minus 3 raised to 4x over x as x approaches to 0. So let me just show you that this is not possible if we do direct substitution. Okay? So this is what will happen if we apply direct substitution. So that would be 4 raised to 3 times 0 minus 3 raised to 4 times 0 over 0. Let's continue. 4 raised to 3 times 0, that's 0. Minus 3 raised to 4 times 0 is 0 over 0. Let's continue solving. 4 raised to 0, that is equal to 1 because any number that you raise to 0 is equal to 0. And then 3 raised to 0 is equal to 1. So minus 1 over 0. We are not yet done. So therefore, let's continue solving. 1 minus 1, that's 0 over 0. This is indeterminate. So we have to simplify this. Let's solve for it. And this is what we are going to do to solve for this kind of equation. We have to get the derivative of the numerator and denominator. So it will look like this. This is solution 2. This is solution 1. For solution 2, we have here the limit of 4 raised to 3x minus 3 raised to 4x over x as x approaches to 0. Then we have to get its derivative. So this is let me just write it here. So this is times d over dx for the numerator and same for denominator. D over dx. Okay. So let's solve for its derivative. So this will be 4 raised to 3x times the coefficient of x, so that is 3. And then we have here 1 minus 1 our exponent should be subtracted to 1, so that is 0. So we will not write it because x raised to 0 is 1. And then the ln 4, and then minus, let me write it here, 3 raised to 4x times the coefficient of x, so that is 4. And then for our exponent of x, for this part, beside 4, so we have to subtract 1 and 1. So that's 0. We don't have any variable now. So therefore, this is ln 3 over 4x over the numerical coefficient of x. So that is 1 here. And then for our exponent here, that's 1 minus 1, so that's 0. So no need for us to write x raised to 0 because that is equal to 1. Okay, then let's continue solving for this. The next step that we are going to do is to substitute the value of x, that is 0. So it will become 4 raised to 3 times 0 times 3 ln 4 minus 3 raised to 4 times 0 times 4 ln 3 over 1. And let me just erase this part so that we may continue solving for this equation. Let's continue. So now we have here 4 raised to 3 times 0, that's 0, times 3 ln 4 minus 3 raised to 4 times 0, that's 0, times 4 ln 3 all over 1. And then let's simplify. So we have here 4 raised to 0 is 1, because any number that you raise to 0 is equal to 1, times 3 ln 4 minus 3 raised to 0 is also 1, times 4 ln 3 all over 1. Then let's use our calculator now to simplify this. 1 times 3 is 3, so we have here 3 ln 4 minus 4 times 1, that's 4 ln 3 all over 1. So if we direct this into our calculator, we will get negative 0.235566, or we can just write negative 0.24. So this is the answer for example number 4. So I hope that you have learned something today about this topic. If you have questions or clarifications or inquiries about us, kindly message the Honors Tutorials page.